Hello class, we are in lecture 38. We will go over a case study regarding health. I'm your instructor, Ms. Laura. As we talked about in last week lecture, we already finished all the lecture from the textbook in chapter 1 to 18. That's in our module 1 to 13. So for this week, module 14, we don't have more lecture we want to introduce to you. However, we want to go over 2 case studies to see, to apply on the data what we already learned from this class. So today's lecture, we will have the case study focus on the health example. Then the last lecture, we will do the education. So that will be our week 14 for this week. We still have week 15, and week 15 next week is totally no lecture video you need to watch. So module 15, you only have to work with your partner or your classmate for your last project. So that for week 15. And week 16 will be just final exam. So since we don't have any more lecture video in module 15 and 16, so just pay attention on the announcement, especially for the due date for your final for your not the final project, your last project, project 3, and also your final exam. In the announcement, I will talk about what will cover in your final exam. Just heads up, your final exam will still be 2 hours, 100 points, but that will be comprehensive from module 1 to 15, everything we cover for this class. Okay, so that's our lecture 38. We see our case study health. But before that, I noticed actually some of you have the confusion about our lecture. In lecture 37, we talk about the conditional probability. We kind of give you more updates from the probability. We introduce base rules. But maybe in the wording or our example confuse you a little bit. So that's why before the case study, I just want to spend a few minutes to review your probability first. Okay, so that's the example we have in lecture 37, if you remember. So let me refresh your memory. So here, actually, we just talk about in one class, we have the student. We don't know the total number, but we do know the ratio. We have 60% is second year, student in their second year, and we have 40% in their third year. So addition to this information, we also know among all those second year students, half of them declare their major. That's on the other hand, that's me. The other half, they not declare their major yet. So then from the third year student, we have 80% they declare their major. So on the other hand, you have 20% undeclared major. So this information you see we make as a tree diagram because sometimes when we have our probability, even they are the same in the same group, but they have multiple rows. So that's why here we have the phase 1. We know the students according to their year. We have second year and the third year, we have their ratio. But among that second year and third year students, they have other ratio that's for other information. But in our tree diagram, remember, we can expand each branch. So we continue with the more branch. But each branch set you spread out, they have to add to 1. Because remember, we want to have the probability is for the 100%. Then they can spread out as well. Okay, so I think last week in the lecture 37, here is we confuse you a little bit. We pick a student at random. So here I want to kind of rephrase to make sure you understand our example, actually some correction for our lecture 37. So right here, if we pick a student at random, Okay, so then I want you to give me the probability. Okay, so the first question, what is the chance I pick a student at random? The student is in the second year. Great, actually we only need to focus on here, right? Because I only asked you this student is second year. So on the other hand, if not, they are in the third year. We only have this one, right? So we only focus on this branch. So then you tell me that's 60%. Great, that's correct. So then that's the probability we talked about before the lecture 37. Okay, but also I can ask you what? I can say, I pick a student at random. So what is the chance that student is in the second year and major declared? So this one, right, this one is before we talk about that's combined probability. I have the students pick at random. They need to meet both conditions. So they can be the second year or third year, but since I only focus on the second year, okay, so then the major is declared. So that's why here is the major declared. So then we have this 0.6 times 0.5 equal to 0.3. So that's 30%. Right, this one we call the combined probability. Okay, so last week, I think I get one the slide not clear is when we talk about pick a student at random. Okay, because before this slide, we already say later on we introduce our conditional probability, right? Okay, so actually this one is in the lecture 37 we introduce you. So I want to make the correction here because in this slide before we already say, oh, we pick out a student at random, right? At random, and we know that student declared the major. So that's why here when I say pick a student at random, I should give you more information because continue from the previous slide, we say this student we pick at random and we find out the student major is declared. So this one is we call the conditional probability. Because I'm not taking any student at random. Actually, I already know this student is major declared. So this one, on the other hand, we should rephrase that. I can either say I pick a major declared student at random. Okay. So then, right, so you need to be careful. And this one is we talk about is the conditional probability. Because when I pick a student at random, I already have some condition on that. We know that student is major declared. So that's why here when we want to find the chance, okay, I know that student have major declared. So what is the chance the student in the third year? So right, this student is major declared in the third year. But the condition is different is what? We only, when we pick a student, okay, or I say I pick at random and I already know the major is declared. So that's two wording will be similar. I can say pick out a student, a major declared student at random. Or I pick out a student at random and I know this student, the major is declared. Okay, so that's why that's the condition. So in this situation, since we already know the student major is declared, okay, so remember probability is what? All the possibility for the events divided by the population. But here, since I already know the student major is declared, so my population here is all the major declared student chance. So that's why I need to have second year declared and the third year declared we add together. So here the second year and declared they are 0.6 times 0.5. Then we plus the third year is 0.4 times 0.8. So here total is 0.62. Okay, so that's because the condition I told you here is changed. I did pick out a student at random, but this student is major declared student. So if what's the chance the student is in the second year? So that's why our numerator, we have the second year student with major declared. So that's 0.6 times 0.5. So that's we have our chance to pick up a student is major declared in their second year. So that's here. So that's why be careful about the wording. Okay, so that's why I just want to clarify. Because I think in our lecture 37, we're not very clear for that. And also that's the reason we have the practice quiz for your quiz 37. I have different questions. Since now, last week, lecture 37 will only focus on the conditional probability. But remember now, for your final exam, you need to prepare as a whole when we learn the probability. So be careful about the wording. So in your exam or quiz, you have any issue, you think about the wording is not clear, or you think your answer is correct or something, make sure you will contact me or discuss with your classmate. Okay, so that's a quick review about what our probability for this semester. Okay, so let's really start our lecture 38, our health case study. So about the introduction, okay, so here why we have this case study. Actually, we are finding the lost data. So we have the Christopher Refson. So he is in the National Institution of Health. He specializes in finding the lost study, particularly those with the potential to challenge the mainstream government sectional health advice. So what does that mean? So even now data is blooming, right? So you guys come to ask me, you want to interesting about to do some data science case study. So then I will tell you, you can go a lot of resources online to find your data. Okay, but that's now. But before, actually, especially we have a lot of medical study data. Okay, before we only know those data according to the publisher, about the research published. But sometimes remember, especially before 1970 or even 1990, a lot of study they failed to publish the study because from their research they didn't confirm the hypothesis can mislead the scientific community. So that means they do this study, they have the data, but the conclusion of the test didn't meet the expectation, their original hypothesis. So that's why they never publish. So you didn't publish the paper, you don't publish your data. But also we did talk about, right, actually the data and sampling is so important. So those things, even they cannot support their null hypothesis, but those data is meaningful. Understanding and publishing those historical data can be productive alternative to conduct new study. So that's why Christopher Refson, he researched interesting about the effect of linoleic acid consumption on the human health. And we know the linoleic acid provides perhaps 10 to 15% calorie consumed today. So they can be found in many vegetable oil, like the olive oil, corn oil. So they that were not very popular for human before 1970. So because of his interest about that, so actually they do have a lot of data in the basement. So we call that, this is from a podcast, you can searching for that. That's what we call the basement tapes. What are the basement tapes? And the father, Ivan Frenzel, Dr. Frenzel, that's the father. He's a principal investigator at the study is National Institution of Health funded study in Minnesota heart study. This study linked the human diet linked to the cholesterol and the heart disease. It has some research never published. They never know that until his son also is a doctor. He's the cardiologist One day he received a message say, Dr. Franz, I heard that possibility there might be some